Alright, now let's find absolute values of complex numbers. And to get started, we're gonna have to use the imaginary real plane. So this is imaginary axis, this is the real axis. Okay, and starting with 2 minus 3i, where's this gonna be on this plane? Well, we have the 2, right? So 1, 2, and down 3 units because we have the minus 3i there. So that's where this point is sitting. And the absolute value is actually just going to be just the distance between the origin to that point. So how are we going to calculate that? Well, that's going to be a piece of cake. All we need to do is use Pythagoras and use this triangle right here to find this distance. So we already know that from here to here that's 2. From here to here that's just -3, or the distance is just 3. So the blue line here is just going to measure, well, let's just call it, if we call it x squared is just going to be, whoops, no square root yet, 2 squared plus 3 squared. So x squared is just going to be 4 plus 9. So x will be the square root of 13, because 4 plus 9 is 13. So this is what the blue line is going to measure, and that is the absolute value of this complex number. That's it. How about number 2? The absolute value of 5 plus 3i. So where's that point? So we're going to go 1, 2, 3, 4, 5 units right here, and 3 units up because of the 3i, positive 3i, so we go up. So we're interested in the length of this line, and that will represent the absolute value of this complex number. Okay, so now we're basically making another triangle. We're also going to have to solve it, or find that distance through Pythagoras. Okay, so here we have 3 units, and sideways we're just going 5 units, right? From here to here. So what is this going to be? I'm going to call it just m, whatever letter, I'm just picking a random letter. So m squared equals 3 squared plus 5 squared. So m squared will be 9 plus 25. So m squared will be 34. M is then going to be just the root of 34. And that's it. So m is 34, root 34, sorry, and x is root 13. There we go.